My name is David Allen. I'm a partner solution architect with Neo4j. A lot of what I've been doing over the last year with Neo4j is about to become apparent. This is a big part of my job is working with the public cloud platforms, Google, Amazon, and Azure, and trying to make it simpler and easier to run Neo4j wherever you need to run it, with this focus on cloud support. So that's what we're here to talk about today. As we go along, I would really encourage you to just kind of put your hand up if you have a question. I kind of like to keep it interactive. It's a little bit more fun and interesting for everybody in the audience as well. So let's get started. So in 2018, we did put a fair bit of focus on cloud. And why is that? When we go out and we talk to our customer base, we hear that about 50% of them are already running on public clouds. And so we set out to make it a lot simpler to launch Neo4j in the cloud. One of the things that we noticed is of the customers who were already deploying on public clouds, typically the way they were doing it is they were creating bare VMs and they were installing the software from scratch on those VMs, like as a Debian package or as an RPM, and then they were doing their configuration themselves. And this works perfectly fine, but we saw an opportunity to make that process a lot easier and also get people set up with a known good configuration that would just work out of the box and let them focus on customizing only the bits that were specific to their problem. And so at the same time, though, we wanted to provide some flexible options for power users. Like there are easy, simple ways to get started, but everybody has their own particular challenge that they need to address, and real systems operators and maintainers need options to do whatever it is that they might need to do specific to their use case. All right. So basically all of this happened this year. Today we're going to talk about three major clouds, the three biggest by far that we see the customer base and the community using: Amazon, Google, and Azure. And across the columns, there's a lot of different options here. We're going to speak about these options in broad terms, but if you have questions about any one of them, we can go into it. So single instance, by that I mean the kind of Neo4j that you get if you run Neo4j desktop. You want a single machine, standalone, not a cluster. This is really good for rapid prototyping, doing a proof of concept within your company. It's not a high availability type of setup that you would put into production, but it's frequently enough. In the cluster world, that's where we're talking about causal cluster, where you get into this notion of core nodes and read replica nodes, and you need the ability to flexibly scale a cluster like that. And then next after that comes containers. So in the cloud, some folks are running these as virtual machines, which we want to support and which is absolutely acceptable. And other folks want to use the Docker container. And so in the Docker world, we've got some added support there. And then finally, in the last column, we've got Kubernetes, which is if you want to run a clustered setup in a containerized environment, typically that's when you're going to start looking at something like Kubernetes. And we'll talk a little bit about that as well. On the very bottom row, Azure is something that I'm actively working on right now. I was pushing as hard as I could to get it live before today's event. I have to still clear the Azure Marketplace process, but this is expected by October. So I'm kind of giving myself a green check there, but it's not today. We'll talk a little bit about that. All right. So, yes, sir.
Just wonder, like, they're going to be like in the future, just like I want a relational database, then I'll just add them on the like a graph database, something like that.
Yes. So there's a product that Neo4j has been working on called Neo4j Cloud, which is going to be hosted and managed. Some of the options we're talking about today are going to be things that you're going to manage for yourself, but at the same time, the answer to your question is yes. That's also coming. This next thing applies to all of the offerings we're going to talk today. They're all bring your own license. So when you go and you consume software from a cloud platform, there's a couple of different models for that, and we've adopted a bring your own license model. What that means is you go into the marketplace on one of these cloud solutions, you launch our stuff, okay? We are assuming that you have a license, and you need to have an enterprise license before you do this. If you want to use community, of course, anybody can do that for free at any time. But what's not happening is obtaining a license through the cloud computing provider and then paying us X dollars per hour for that license. Okay, yes, sir.
If this comes up later, let me know.
Sure.
Then
So typically it means one container, yes. However, if you're operating under a discovery bundle and you have something specific that you want to do, you should talk to your Neo4j rep and we're going to work something out, because it's intended that folks who have enterprise licenses can do these things. Okay? So before we go too deep further, I also want to talk about what it costs. And the idea here is that when you launch something on a public cloud, you're going to pay the cloud computing provider for infrastructure, and that really has nothing to do with Neo4j. You buy a bigger box, you're going to pay more per hour. You buy a smaller box, it's going to be cheaper. As far as the software licensing is concerned, you have an existing relationship with Neo4j. It's governed under the terms of that license, and there is no additional charge for using any of this stuff. So if it's community, all you will ever pay is the VM time on the cloud computing provider. If it's enterprise, it just depends on your license. By the way, if you're out there in the community, maybe if you're a grad student or you just want to get started trying Neo4j, most of the clouds have a free pricing tier. And so a really small instance you can have basically with a credit card account and no commitment on any of these clouds for no money. So let's talk a little bit about deployment considerations, and then we'll get into what all of these options are, just so that when we talk about the options, it kind of makes sense in context of your choices. So cattle versus pets. How many folks are familiar with this concept? Yes? Not that many, actually. OK. So in server management and in infrastructure management, we talk about cattle versus pets. And pets are machines that have special names, like Frodo. And they are unique and they're hand cared for. And when they get sick, we nurse them back to health. And so you have an operations staff that focuses on keeping these machines running like clockwork. Cattle, on the other hand, are machines that have numbers like pod 01. And typically, from an operations perspective, we try to look at them as completely identical to all of the other cattle that are out there. And when they get ill, you get a new one. And so your operations staff tends to think about things like how to automate creating a new one and how to automate things like backup and restore, and does not tend to focus on things like how do I SSH into this machine to fix this nasty problem, okay? And so when we think about cattle versus pets, let's talk about virtual machines. Well, what are they? Basically, it's a bunch of virtual machines running on top of what the cloud computing provider has is one big physical box. It virtualizes the hardware and allows you to run multiple operating systems on one big blade server in a data rack somewhere. The pros is that you can have fewer flexible VMs that have multiple workloads. And so a lot of times people will use a VM when Neo4j is not the only thing running on the machine. They have an analysis process or some sort of a cron job or any number of other things that are also running on the machine. They're also easier to migrate to if you're coming from existing legacy software or legacy platform. The cons is that they tend to be heavier on resources, and you're going to find that most often they get managed as pets. So if you run a lot of different processes on a single VM, you're going to get into the mode of operating that and maintaining that over time. And so typically virtual machines get deployed as pets. Containers, on the other hand, it virtualizes the entire operating system. And so basically, you tend to put only one thing in a container. A container almost never runs 3 different programs inside of it. It's only one thing, like, for example, Neo4j. And then you just put lots and lots of containers on one machine. So it's a different way of thinking about the same problem. The pros is that it's light, it starts fast, it doesn't have as much memory management overhead, and it's way more portable than a VM. So you can pick up a container and you can move it to a different cloud computing provider if you wanted to. The cons is that they kind of create their own problems in a sense, in that once you get fluent with using containers, you often buy yourself the problem of now having too many containers and having to manage and orchestrate all of those containers. And they also need careful security configuration, and there are some special considerations in the security world for containers. On the other side, they typically get managed as cattle, and so people don't usually SSH into a container and fix a problem and keep the car rolling down the road. What they instead do is they throw the container away and then they spin up a new one, and they still have their service in place, and they didn't really have to maintain it. They just execute it, make a new one. And that's really cattle versus pets. OK, so this is all bringing us around to how this applies to Neo4j. We have a couple of different approaches that we support, and then we'll talk about what they all are and so on. Some are template-based, and some are roll-your-own based. And so in the template world, basically what you're doing on a cloud computing provider is saying, I want to deploy a lot of resources. Neo4j is just one of them. I might want to create a virtual private network, multiple IP addresses, some host names for those databases. And then we want to wire it all together into a working cluster in a particular configuration. We're going to provide templates for that. So on AWS, they have a technology called CloudFormation, which is just a way of expressing this template and deploying a set of resources. On Google, it's called Deployment Manager, but conceptually, it's exactly the same thing. And on Azure, it's again exactly the same concept, just with a different marketing name called Resource Manager. And so the pros here is that it's a really fast startup. So if you said, I've got 10 minutes and I need a cluster, this is the way that you want to go. I can give you a cluster really quickly and it's just going to work. The downside to the templated approach is that I had to make some decisions for you. Okay? I can't have perfect knowledge ahead of time of what your company's IT structure is like. And so maybe you need it deployed into this VPC or you need this particular security configuration. Maybe that template doesn't do that for you. Okay? The focus of the template is to get you up and running quickly with a known good configuration for a complicated cluster setup. The second option is to roll your own. And so what we can do is provide raw containers and virtual machines. Now, how many folks have used like the regular Neo4j packages like RPMs, Debians, anything like that? Yes? Okay, so in the roll your own world, using an Amazon image for Neo4j is just basically like the ability to start a new virtual machine that has Neo4j pre-installed and configured. But that just gives you one machine. If you want to put 3 into a cluster, you need to do that configuration yourself. Okay? If you're trying to get started quickly and easily, that's a con. But if you have very bespoke requirements that you have to satisfy, it's a pro. Okay? So the overall message here is that we're going to try to provide a lot of different things to you, and we're happy to provide additional help and guidance on choosing if that's useful to you, but we want to try to support a lot of different methods and modes of deploying. Any questions? Okay. So cloud availability. I personally think of the cloud images as being a lot like the other packaging formats. So if you run on Windows, you want a Windows packaged version. If you run on Linux, you want a Debian packaged version. Well, in today's day and age, the cloud platforms are just other platforms like Linux or Windows, and you want to be able to run it on AWS? Okay, we want to meet you there. We want it to be easy to do that. By themselves, they require that installation and configuration. So out of the box, you can launch it, and what you'll get is a single node that just works. Is that configuration optimal for your case? Probably not. You would probably want to go in and configure that as you saw fit. And yeah, we already covered this. The templates are reasonable best practice defaults, but still may require design. I've had a couple of customers approach me where they saw the templates and they said, well, I don't like your template because my security topology works like this and your template doesn't do that. And so we give them the template and all of the bits and pieces and show them how to change it. But designing it for your IT architecture is ultimately something that has to be done company by company. Okay, so a couple of things that are different about the cloud distributions. When you download Neo4j off of the website, you get Neo4j. When you run one of these cloud instances, you're going to get APOC and graph algorithms installed automatically. Typically, when I first started publishing these, the Amazon images in particular, 100% of my early requests were, could you put APOC in? Because pretty much everybody wanted to have APOC. So now it comes packaged with that by default. If you're in the if you are in the roll your own mode and you don't want to use APOC because of local security restrictions, you can simply remove it. But we wanted to make it immediately useful. We also have a series of cloud startup scripts. For folks who are not used to operating in a cloud environment, it's much more dynamic than working inside of a data center in that You can have a machine that has a dynamic IP address, and then you shut it down, and then you restart it, and it comes back alive with a different IP address, right? And so we've added some extra things into this to keep track with that, so that your default advertised address, the thing, how your node talks to the rest of the world, will keep pace with IP address changes and so on. We also have some community support that's available. How many folks have signed up for the Neo4j community site? Anybody? Okay, if you don't have a user account on that, you might want to check it out, because increasingly there's a lot of great technical content and blogs and discussion and Q&A. And some folks have professional support channels, which are also really excellent to go through. But if you're just Googling around, in the coming months, you're going to find a lot of technical answers coming from that site, as we've published knowledge base articles and troubleshooting articles and all kinds of other stuff out on that community site. It is community.neo4j.com. Okay, so with all that out of the way, and let's talk a little bit about AWS. Okay, so first entry I want to talk about is, if you're on AWS, you probably know about the Marketplace. This is AWS's concept where you go search for a solution, you press a button, you answer a few questions, bam, solution deployed. Marketplace causal cluster is out there. You can find it today. And when you subscribe to this in Amazon's language, it's going to ask you some questions like, how big do you want your machines to be? How big data disks do you want attached to them? How many nodes in your cluster do you want? And that's about it. There's not a whole lot of technical config beyond that. You click launch. About 5 to 6 minutes later, a cluster is formed, and you end up with an endpoint. You get a Bolt endpoint, where you can directly attach things like Bloom or any apps that you may have. And you also get SSH access. So about all of these marketplace things we're talking about, keep in mind that you still own and operate the VM. So you're going to have root access to all of the VMs that are getting spun up inside of your cloud organization. Oh, right. So on AWS, if what you're after is a cluster formation, this is the best option. And please don't try to write down that URL at the bottom. I intend to distribute the slides. If you want the slides, come talk to me afterwards. I'll get you the link to the slides, and you'll have all the links to everything that I'm talking about today. So in the Marketplace, there's also a community entry. Community is obviously always single node. The clustered deploy isn't supported under community. And this is best if you want a single VM for testing or for open source projects. Like if you want to do the equivalent of Neo4j sandbox.com, spin up a VM, try something out, load some data. This is a quick way that you can do that with pretty much zero setup. When you're done with it, destroy the VM, you're back to normal. All right. Finally, this is the roll your own option in Amazon world. These are the public AMIs. An AMI is an Amazon machine image, I think. And so this is just, it's literally an image of a virtual machine. And Amazon makes it really easy to launch an instance of this and to create a new VM from this. And so if you wanted the ability to have fine-grained control over the configuration, you would do it this way. And just recently on the community site, I posted, well, hey, we've got 3.4.7 with APOC and graph algorithms, and then I gave the AMI IDs. So if you're a developer and you know how to launch this kind of stuff on AWS, it's really as simple as plugging in an ID, clicking launch. Goes very fast. So before I move on to Google, let me pause for a second and ask if Amazon I put first because we find it's one of the most commonly used. So any questions about Amazon availability?
So is it going to support the cluster?
Sorry?
Clustering, like while loading data and reading data from the Neo4j, it will support the clustering?
Yes, this marketplace entry, marketplace causal cluster, supports clustering. Okay. Yes?
Quick question. Do you have any replication in this cluster environment? Like if I have 2 nodes, but content.
Yes, so the cluster is fundamentally replicated. So if the default is that you're going to stand up 3 nodes, not 1. And in the clustered configuration for Neo4j, let's say you have 3 nodes. You can talk to any one of the 3 and execute Cypher. Let's say a disaster happens and AWS loses a data center, and one of your nodes completely disappears. Your entire graph is still available online and available. So if you have 3 nodes, you can lose one, and you can still read and write your graph. If you lose 2 nodes out of 3, your graph is still available, but you can only read it. Okay? If you lose 3, well, I can't help you. In that case, you needed a 5-node cluster or more reliable hardware.
Is this kind of like EMR or EC2?
Sorry?
The clustering is happening on EMR or
EC2.
EC2?
Yeah.
So you are going to launch multiple EC2s and
Yes.
using as a cluster.
Yes. So yes, that's right. On AWS, it's going to use the AMI. It's going to launch an EC2 instance in 3 different availability zones. And the reason for that is that if Amazon has a problem and loses connectivity to an availability zone, you don't lose access to your cluster. Okay? And it's also going to place that into a VPC and set up firewalling rules so that by default it will allow like Bolt and HTTPS in and out. But you can sever that and say, I don't want internet access because this is for my company stuff and I need it locked up inside of a VPC. That's expected. Okay. Yes?
So if you can drop down to 1 node and still use your database, does that mean that the database is replicated, not sharded?
Correct. The data is replicated across. So if you have a graph in a Neo4j cluster, every node in the cluster has a complete copy of the graph. That's correct. Okay. So let's talk about Google Cloud. In the GCP Marketplace, there's an equivalent entry. This is what it looks like. Basically, you go there, you click Launch on Compute Engine, and it's a similar kind of a flow. This is for a multi-node cluster setup. So this is that replicated 3-node cluster setup that has high availability. This will also allow you to create both core nodes and read replicas. In Neo4j's cluster architecture, core node helps you guarantee high availability. That's what you can lose some of. Read replicas help you scale out your read workload. So a common case might be, suppose you have a transactional database. Every day your customers are hitting it, and it needs to be up all the time to handle all these transactions that are coming through. But once a month, you have to do analysis on your database, and you have to run these big, heavy queries that take a lot of memory and a lot of CPU. Well, if you have a read replica in your cluster architecture, it keeps pace with what's in the database, and then you can run those really heavy queries against a read replica and not disrupt your production system. So these templates are all built to allow you to scale that however you would like. So you get to pick how many core, how many read replica. And if you need help with that, again, it's a topic happy to talk about offline, but how you design that and how many nodes you put into which category just depends on what you're trying to do. Yes? Yes, that, I didn't mention that, but yes, it's very similar. You get to choose number of core, number of read replica. Yeah. So in Google has something that's a little bit different. They have a Kubernetes Marketplace. So Google wants to be known for being some of the best at managing Kubernetes clusters. And so they have a managed service there called GKE, Google Kubernetes Engine. They'll allow you to create a Kubernetes cluster. And so over at Google, sometimes the vision is like you're going to have a Kubernetes cluster, you're going to run a lot of workloads on top of it. It's just a pool of nodes, and whenever you need to run some new program, you're going to schedule it onto that pool, rather than create a server for the purpose of running this application. So they recently, at Next 18 this summer, they launched the Kubernetes Marketplace, which is just like a regular cloud marketplace, except it's for apps that run on top of Kubernetes. And Neo4j was one of the launch partners. And so this gives you the ability to configure and deploy a Neo4j cluster into a Kubernetes cluster. That is a cluster in a cluster, which is, yeah. Sorry? Okay. So This is similar to the Marketplace entry where what you're getting is a multi-node cluster of read replicas. It's best if you run Kubernetes, and it's best if you are interested in running a clustered setup and you want to use Docker containers. Okay? Now, why would you do that? Well, there's a bunch of different reasons. Some customers we're seeing are moving towards Kubernetes because of workload portability. So if you have a Kubernetes cluster, you have abstracted away what cloud you're using, and you just have a big pool of virtual machines, and you're scheduling your workload onto that. If you have a GKE cluster, one of the things you can do is you can add a new pool of machines on Amazon, and then you can shift a workload from one cloud to another by simply scheduling it into a different node pool on Kubernetes. And so if your companies aren't doing this now, that's like perfectly okay in that it's still a little bit forward-leaning for some companies. But in the coming years, you're going to see more and more adoption of this type of technology, in part because it frees some of the companies from cloud-specific lock-in for their workloads. Okay? And because Neo4j already had great support for Docker, it was pretty straightforward for us to add this and support it for customers who were asking it. On Google, there's also a Neo4j test drive. So I need to add the link to this, but basically it's a spot where, can I one more show of hands. How many people have used Neo4j sandbox.com? A few? Okay. Neo4j sandbox.com and Google Test Drive are similar in that they are an environment where you can go and launch a graph that's time limited. So they're going to give you a small node for free. No sign up. You don't have to even have an account with one of these cloud providers. And you can create a graph. I think it's 3 days. It might be 5 days. And in this particular test drive, it comes pre-populated with data. And so if you're at the learning stage and you want to play with Cypher and you want your own little sandbox where you can just kind of mess around and try things out, this would be the ideal way to do that. It has browser guides built in, so when you show up, you're not just going to end up with an empty screen, but it's going to start you on a tutorial and say, all right, here are the basics of what a graph database is, here's what nodes and relationships are, and here are some interesting queries that you can run immediately and see results. Okay? So this is really tutorial oriented. You would not run this in production, but if you have folks in your organization who you'd like to understand what Neo4j is and what it offers, this would be the ideal new user entry point. Finally, on Google Compute Engine, which is Google's term for EC2, right? They all have very, very similar offerings with different names that are conceptually the same. We have a number of images available. And this is, again, the roll your own VM deployment option for Google Compute Engine. Again, check with me on the slide link so that you don't actually have to write these things down. All right, Microsoft Azure. This is in progress. So if you go to Azure Catalog right now, you're going to find HA available, Neo4j HA. That's the high availability product that came before our latest causal clustering product. We're working on deploying all of these things that we've talked about for Amazon and for Google, basically exactly the same concepts, but now for Azure as well. So you're going to have basically templates for clusters, images for single nodes, and an easy way to deploy a single node. And we're working with Microsoft to get this published as quickly as possible. The engineering on it is basically done. We're just kind of working through the process of getting it approved on their marketplace and listed and all of the hoops you need to jump through. Okay, a little bit more on running Docker containers. Up until now, we focused really heavily on virtual machines. If you want to run bare Docker containers and you don't want to do Kubernetes because that's a step too far for you, all of these cloud computing providers give you easy options. So on Amazon, that's called ECS. In Google, you can either use Kubernetes or you can also basically run a VM on, run a Docker container on top of a VM, and you can create a VM whose sole purpose is to run a Docker container for you. And on Azure, it's the same thing again. You can basically deploy Docker Enterprise Edition, and then you can run containers on top of that. So this is a different option that some people use to do the equivalent of roll their own of Neo4j. The one thing that I would not recommend to you, one thing we've seen a couple of customers try, is that they say, well, I want a cluster of 3 Neo4j machines, so I'll set up 3 individual Docker containers, and I will manage the connections between them. That is possible. It's just way more pain than is necessary. So we wouldn't recommend that you do it that way. In the Docker world, Docker does not come with APOC by default, but it's really easy to add, and I can show you how to do it in 5 minutes. And we are also doing a lot of work in the background right now on improving Docker documentation. And so there are some edge cases and some more advanced things people are trying to do with the Docker container that are supported, but we need to be doing a better job of explaining that in clear terms so that people can get started and get running really quickly. I want to talk a little bit more about Kubernetes. There is this thing called a Helm chart. And so a Helm chart in the Kubernetes world is like the templates that help you describe what a cluster is, what all the resources are, and how they connect to one another. Neo4j offers a public Helm chart, so you can go out to this particular GitHub repo, and if you're running Kubernetes but you say, hey, GKE is not for me, you can deploy Neo4j on any Kubernetes cluster using this set of open source artifacts, and basically you just create a copy of the repo, you type one command, as long as you're authenticated against your Kubernetes cluster, and that's about it. The nice thing about this too is that it's both template and roll your own. Because you're getting the chart, if you have local Kubernetes people who say, I don't like the way they did that at Neo4j, I want it configured in a different way, you already have the source code, and it's out there in open source because that's a pattern of ours. So in the Kubernetes world, this is what's happening. So in Kubernetes, they refer to pods, and a pod is just like a machine that's running. Pods are basically just instances of the Docker container. So we take the container, make a new machine out of it. That's a pod in Kubernetes land. And Kubernetes also has this concept of a replica set. What's really cool about the way that they manage stuff for you is that you can say, I want a cluster, and it needs to always have 3 machines. What happens if one of those machines has something bad happen to it, or fails over, or the underlying hardware fails because some power supply or some disk somewhere failed? Okay? Kubernetes says, you told me to keep 3 machines running at all times. So if I see a problem on one of them, I'm going to kill it, create a new one in its place that's just a copy of that, and you always have 3 machines available. And so you can see situations where an underlying hardware server may have a problem and may cause one of your nodes of your cluster to fail, and you wouldn't even notice it because Kubernetes creates a new one under the covers, knits your cluster right back together, and bam, you keep going without even noticing that. Somebody in a data center is going to notice when their power supply or when their disk failed, but you don't want to have to care about that. So at the very bottom, the underlying nodes are the VMs or the hardware. And so this is what I meant earlier when I was talking about the pool of resources. So what we're seeing some companies do increasingly is that they have a fleet of 200 machines, 500 machines, whatever the number is. And all of the workloads, whether it's a marketing application or a customer-facing system or a database or whatever, it just gets put onto that pool. Okay? Now, within that pool, if you start operating hundreds of machines, almost every month one of them is going to fail, just because those are the numbers. But if you have a flexible management framework on top like Kubernetes, you've abstracted away some of those problems, and you might not even notice even through some of those IT disruptions. And so that's one of the cool kind of compelling things about containerization and Docker, but it ties back to that concept we were talking about earlier of cattle versus pets. Like if you're taking care of each machine carefully and individually, it's very difficult to operate in this kind of a mode because you need to have it set up so that management technology like Kubernetes can be told, this is what a good healthy machine looks like. If you ever have a problem, just make me another one. 'one. And so that implies more automation and less manual work, which in turn is what helps us go faster. This is the last thing I want to talk about, and then we can get into some of your questions if you have some, and that's network security. So databases don't exist in isolation, and they're going to be a part of a complicated architecture that a company has. That raises this really important question of where to put Neo4j into that architecture. And this is something I wrestled a lot with when I was building a lot of this cloud stuff, because in the template world, I had to make some of these choices, okay? So here we've got kind of like 3 setups. In the first setup on the left, you have a virtual private data center. And you have Neo4j talking to whatever applications need to use your graph. And this hard wall here is really a hard wall. Like, no traffic gets in or out, okay? So in this world, if you're at home on your laptop and you try to reach this database, you can't. There's no way to get from here to there, okay? That's on purpose. That's a security measure to prevent random people on the internet from trying to connect to your database or log into it, all right? In the second setup here, we put Neo4j inside of a VPC, but the applications reside outside of the VPC, okay? So imagine that you had a customer-facing website and you're trying to sell some products. Well, it has to be publicly accessible, otherwise you can't do your business. But it needs to talk to something that isn't. You might use that kind of an architecture. And then on the third, you're exposing everything publicly on the internet. Now, exposing everything publicly on the internet is super convenient and easy, and anyone globally can use it, but it will make your security people sweat. Because that means that anybody from anywhere using any exploit they found on the internet can connect to your machine, which would not be a very good idea, okay? So takeaways from this are that like VPCs provide these security boundaries, and they allow you to audit and enforce things. And this network segregation, where we chop up the network and we create gates, and we only allow traffic through at certain points and only under certain conditions, is good operational deployment practice, but it requires careful thought and planning and configuration. We definitely recommend that for production as part of like a good network security posture for deploying Neo4j. When we did some of these cloud templates, we have to strike a balance. In general, we make it so that when you deploy Neo4j in the cloud, you're going to automatically get something that you can connect to from the internet, all right? And so that's one of those things that you're going to want to look into before you go to production with some of these templates and AMIs, is that overall security architecture of where it fits, what applications it needs to talk to, who's allowed to log into this thing to make sure that your data stays secure and not just available.
On the second architecture, how would you go ahead and keep app1 and app2 able to connect to the database but keep the world at large out?
Yeah, so that hard boundary of the VPC, you create what are called ingress and egress rules, like who's allowed to get in and out. And so frequently what you would do is you would say, if you're coming from this IP address where I know my application runs, it's allowed to talk bolt to the database. And if you're coming from some random IP address of somebody at home in New York City, what happens is the traffic arrives and simply drops on the floor. It doesn't get to the database and get refused. It simply never arrives. Does that answer the question? Okay. So a couple of conclusions. This year we put a lot of work into this. Elevating up above all the technical detail we've talked about, you can go from 0 to a scalable cluster in 5 minutes on these cloud computing platforms now. You go to one of those marketplace entries, you click configure, you plug in some variables, 5 minutes later you have a working cluster. It's that simple. You can use single machines, and you can use enterprise as you need it. We try to always provide love for our community users. A lot of the times we find that the folks who are using community today are the ones that are going to be the customers in another couple of years. And please come by the community site. Let us know how we can make this better. And so this is really for you guys. It's for the community. And so if you try this stuff out and you say, well, this isn't quite right, or I'd really like to see this, The other day, somebody on the community site said, well, I want it available in this particular region. We'd love to hear about that from you. Thanks very much.